Hello everyone, my name is Varun. In this video, we are going to discuss about F5 cookie persistence. So one of the common requirement of load balance application is that a client must stay locked to a single server for the duration of the session, since most of the application servers maintain session information on local box, and the ability of load balancer to keep a client locked to same server is known as persistence. So in case of persistence, a load balancer will forward the same client request to single pool member until that is available. So how persistence work is, let's say you have two web servers. So you have two web servers, right? One is web server 1, other one is web server 2. Right? These are the two web servers. Let's say this is the web server 2 and this one is the web server 1, right? And you have a load balancer that is performing a load balancing for this application. Okay, so F5 is doing the load balancing for these two web servers. Now when a client sends a request to the F5, F5 will first send the request to any of the web server, either web 1 or web 2, based on the load balancing configured. Now let's say client sends the first request and F5 has forwarded it to web server 1. Now whenever the request will come from the same client or same session, F5 will send the request to web 1, not to the web 2. So there are many persistence method available in F5. Commonly used are cookie, source IP and SSL session ID. But in this video we are going to discuss about cookie persistence. So how cookie persistence work is, just clear this. So how cookie persistence works is, let's say this client sends the HTTP request to the F5. Now F5 will do the load balancing on the basis of the load balancing method configured, right? And let's say F5 forward the request to the web server 1. This HTTP request F5 forwarded to web server 1. Now while replying to this request, while doing a response to the request, either web server or F5 will add a cookie in the HTTP header. Now what F5 does is it makes an entry for this cookie, right? And whenever a client will send a new request, so this response F5 received and forwarded to the client. So now plus cookie. Now what client does is, when it receives the response, it makes an entry for this cookie in its browser, right? So whenever client will send a request to the F5, from the second request to the F5, it will add a cookie to the request. Now F5 will check this cookie and then it will forward the request to the same pool member. So the request will be going to web 1 if the cookie which client is sending is the same which F5 responded for the first request. So this is how cookie persistence work. So cookie persistence enforces the persistence using HTTP cookie. As with all persistence mode, HTTP cookie ensures that the requests for the same client are directed to the same pool member after BigIP system initially load balances them. If the same pool member is not available, system will make the new load balancing decision. This is what we discussed. Now there are multiple methods of cookie persistence in F5. First method is the cookie hash. So the cookie hash method consistently maps a cookie value to a specific node. When a client returns to the site, BigIP system uses cookie information to return the client to a given node. With this method, web server must generate the cookie. The BigIP system does not create the cookie automatically as it does when you use cookie insert. So how cookie hash work is, let me clear this. So yeah, so with cookie hash, the requirement is that the application or the pool member should insert a cookie with the response. So in cookie hash, F5 will not add the cookie, but what it will do is, let's say as we discussed, let's say the first request from the client come to the F5, F5 forward the request to the web server 1 basis on the load balancing method. Now what web server 1 required to do is, it is required to add a cookie in the HTTP response. Now when this response comes to the F5, F5 will calculate a value based on this cookie using the hash length and hash offset, and will make an entry of that value in the persistence table, and then F5 will forward this response to the client, right, with cookie. Now client has received the cookie. What it does is, it makes the entry of this cookie in the browser. So whenever the client will send the next request, it will add that cookie in the request. Now when F5 receives this request, it will again calculate the cookie using the hash offset and hash length, and it will get a value. And if that value matches the persistence table of F5, then it will send the request to the same web server. So if we discuss the steps of cookie hashes, so first request is load. So one of the requirement of cookie hash is that the web server or the pool member has to add a cookie. F5 is not going to add a cookie. It will only add a cookie if you use cookie insert method. So how it works is, first request is load balanced on the basis of the load balancing method configured, right? When the pool member sends the response, the big IP system passes the set cookie header and uses the hash offset and hash length setting in the cookie to compose a value based on the hash length and offset in the persistence profile. The big IP system stores the value in the persistence table, and when the client sends a subsequent request containing the cookie, big IP system passes the cookie header and uses the offset and length setting to determine if the value matches one stored in the persistence table, and if it matches, then F5 sends the request to the same backend server. This is how cookie hash work. So with cookie hash, web server adds a cookie. F5 once receives the cookie, calculate a value on basis of offset and the length configured in the persistence profile, and it makes the entry of that value in its persistence table, and it sends the response with cookie to the client. Client sends the next request with that cookie. Now again F5 calculate the value on the basis of hash offset and length, and if it matches the persistence table, F5 will forward the request to the same pool member. Next method is cookie insert. Using the HTTP cookie insert method, the information about the server to which client connects is inserted in the HTTP header of response from the server in the form of a cookie. By default, cookies named is big IP server pool name, and include the encoded address and the port of the server handling the connection. The system sets the expiration date for the cookie based on the expiration setting of the cookie persistence profile. HTTP cookie persistence is a default value for cookie method setting. So with HTTP cookie insert, how it works is, let me clear this. So we have two web servers. F5 doing the load balancing, and the client sending the request. Okay, so in case of cookie insert, it is similar for the very first request. So as client sends the HTTP request, F5 does the load balancing, and let's say it forward the request to the web 1. Okay, so it sends the request to the web1, okay, then this is web2, okay. Now in this case, web server is not required to add a cookie. It will simply send a response, HTTP response. Now when client receives the HTTP response, it will add a cookie to this response before sending the client. So what F5 does is it adds the cookie into the response. So web server sends a response without the cookie, and F5 adds the cookie to the response. So press cookie, and this cookie contains the value of the pool member from which F5 receives the response, and then F5 sends this response plus cookie to the client. Client again enters this cookie value in its browser. Now with the second request, F5 the client again adds the cookie with the request, and F5 checks the cookie and see which pool member this cookie belongs to, and will forward the request to the same web server. So with cookie insert, there is no need of configuring cookie on the server or the pool member. So first request will be load balanced on the basis of the load balancing method configured. When selected pool member send the response to the cookie response, so this would be the point number 2. So when a selected pool member sends a response, cookie is added F5 before sending to the client. So in this cookie insert method, F5 insert the cookie in the response, then client saves the cookie in the browser and sends the cookie in addition to the HTTP request. F5 LTM sees the cookie value and sends the request to the same pool member. Third method is cookie passive, HTTP cookie passive. Using HTTP cookie passive method is unlike of other cookie persistence method. The BIG-IP system does not insert or reach or search for a blank set cookie header in the response from the server. This method does not try to set up the cookie. With this method, the server provides the cookie and format it with the correct server information. So with cookie passive, F5 will not gonna insert the cookie, or it's not gonna calculate the value on the basis of cookie. The responsibility of adding a cookie is of web server. So when a request comes to the client, F5 will forward the request to the web server. Web server is required to add a cookie, and F5 will not do anything. It will simply forward that response to the client. Now client will send the cookie that is sent by the web server, and on the basis of that, the load balancing will be done. And the last method is HTTP cookie rewrite. Using HTTP cookie rewrite method, BIG-IP system intercepts a set cookie header named BIG-IP cookie sent from the server to the client and overrides the name and the value of the cookie. The new cookie named is BIG-IP server pool name, and it includes the address and the port of the server handling the connection. So with HTTP cookie rewrite, what F5 does is, when the server respond or the pool member respond to the request, it passes the request, it passes the HTTP header and check for the set cookie, and then it will rewrite that cookie which is sent by the web server with its own cookie that is named as BIG-IP server and a pool name, and it also includes the address and the port number of the server handling the connection. And whenever next request comes on the basis of cookie, F5 sends the request to the same pool member. So default cookie format looks like this. So whenever F5 rewrites or F5 inserts the cookie, the default cookie looks like this: BIG-IP server, then the pool name, then the coded server IP. So it contains the server IP to which the first request was sent, along with the server port. So whenever requests come with this with this cookie, F5 is aware what was the server IP to which the first request was sent, as well as to the port, and it sends the same request to the same server. So this is how the cookie looks like. This is the cookie: big IP server, then the pool name web pool, then the encoded server address, and then the port number, coded server port number, and then it inserts 4 times 0. So now we are going to check in our lab how cookie insert works. So this is our laptop topology. So we have a client having the IP address 192.168.31.1. The virtual server IP address is 192.168.31.10, and the pool member IP address is 192.168.31.30, and the other pool member IP address is 192.168.31.20. So let me log in to the F5. The F5 management IP is 192.168.111.20. So in order to configure a cookie, you have to go to the local traffic. Under local traffic, go to the policy. Under policy, go to the persistence. So we are going to create a new cookie, a persistence profile. So let's say I enter the cookie underscore. So I'm going to create a cookie for insert method. So I'll name it as cookie underscore insert. Persistence type would be cookie. Parent profile cookie. Now here we have to select cookie method. So there are 4 available cookie method. One is cookie hash, another one is cookie insert, cookie passive, and cookie rewrite. So in this lab we are going to check cookie insert. So I'll select HTTP cookie insert. Now there is an option of expiration. So either you can check it as session cookie, or if you want you can enter expiration time for this cookie. So if you select session cookie, this cookie will be valid till the browser is open, or till the browser is available, till the request is coming from the same browser. Then that cookie will work, and as soon as you closes the browser, this cookie will not work. If you want to set a particular expiration time for this cookie, then you can set it here. Let's say we use session cookie, okay, and we have an option to encrypt this cookie using this. Now we finish it. Now we go to the virtual server. So the virtual server IP is 192.168.31.10, and we apply this persistence. So we go to the virtual server, then we select the virtual server, go to the resources, and then apply the cookie. So we are going to use cookie insert profile update. Now to check how cookie works is, we are going to start the packet capture. So let's configure the packet capture. DMSH. I'm going to save this packet capture under var directory named as web1.pcap. Simply I'll name it as web.pcap. capture on the virtual server 192.168.31.10. So this is the, just a minute. Sorry, this should be TCP dump. So this is the correct command. So we are going to configure the packet capture, and the command is tcp dump -ni. We are going to take the capture on all the ports, so port will be 0.0 colon nnp. Then we are going to save the packet capture file as web.pcap under the var directory, and we are going to perform the packet capture on this virtual server IP. So hit enter. Now go to the client browser. Let me just clear the cookie. So I'm going to clear the cookies. Now let's browse the virtual IP, virtual server. So this request gone to the 31.20 web server. Now let's initiate one more request. So again the request went to the same backend server. So the first request went to the 31.20, and as we are using cookie persistence and we are using the same session, the other request also went to the same backend server. And now let's check the packet capture. So let me copy the capture file. We are going to use WinSCP to copy the capture file. Okay, so SCP. So we save the file under the var folder. So let's open the var folder. Under this, the file is named as web.pcap. So I'm going to copy this file on the desktop. Let's copy this file. Somehow this capture is not properly taken, so let me again take our packet capture. So this time we are going to save it as web1.pcap, and let me clear the cookie again. We are going to access the virtual server. So the first request went to 31.20. okay, now the subsequent request will also go to the same server. cookie is doing its job. And now let's copy the capture file first. So we go to the jump host, and this is the capture file. Copy it to the desktop. So see, this is the communication between the source and this is the source IP 192.168.31.1, and this is the destination IP 192.168.31.10. So here the TCP handshake is completed. Now the client sent the request. So if we follow this stream, so this is the request from the client. So the first request from the client doesn't have the cookie. You can see this request doesn't have the cookie, but when the F5 responded to the client, it set the cookie, which is big IP server, then the pool name, that is web pool, then the encoded server name, encoded port number, and then 0000. And from next time onwards, whenever client will send a request, it will use this cookie. So if we go to the second request, this is the second request from the client. Now this request has the cookie set. So in this capture we can see the first request from the client was not having the cookie. F5 does the load balancing, send the request to the server 192.168.31.20, and while responding to the client, it added that cookie with the pool details, pool member web pool. This is the encoded server IP and the port number. And when the client sent the second request to the backend server, it inserted that cookie in the request. And this time F5 haven't set the cookie because it found the matching cookie. So here F5 doesn't set any cookie because client is sending the cookie which matched the persistence, and so F5 sent it to the same server and without adding any further cookie. We can also go to the browser and check that cookie. So if I go to the history and if we go to the cookie, so see, there's one cookie for this server, big IP server web pool. So this is how cookie insert work. I hope you like this video. If you like my videos, please do subscribe to my channel and hit a like button. Thank you.